particular series on blockchain training. In the last couple of series, we have seen that at least we started doing some programming, and I hope that by now you might have got some experience of programming in Solidity. The primary idea for programming in Solidity is to learn to build decentralized applications so that we can solve problems meaningful. And for moving on from this particular session, we are relying on 2 or 3 different sources. One of them is Solidity Docs, which we can easily find out by just doing the simple Google search Solidity documents. And this is one of the primary source which we are always referring whenever we are learning something new as well. Now, in this particular session, when we are learning something new, we also need to understand what is the correct source of it. We can always rely back upon it. As you can see that the version currently is going on 0.8.16. Now in this 0.8.16, we are working on this particular model. Today in this session, we are trying to learn how to program ERC720 token. That is basically, what is ERC720 token? Anyone knows about it? What is ERC720? Oh, sorry, ERC20 basically, sorry.
It's a fungible token standard.
Okay. What else do you know about what is fungible and what is that particular standard?
So basically, fungible is something that can be exchanged for a similar thing. Like, for example, money. Like, if I give you a 10 rupee note or if I give you another 10 rupee note, both are equally valuable. And non-fungible is that cannot be exchanged even if they are same. Like, I cannot give you a painting in exchange for another painting.
Great, thank you so much, Chirag. So basically, ERC20 token is a currency, which is a cryptocurrency in one sense. Or we can also think of in our real life, as Chirag said, money. We can also think of any share of any particular company is also similar. So if I have a share of MRF, and let's say Priyansh has a share of MRF, we both are having equal and same, and everything is similar to that. And similarly, if Shiva is having 100 rupees note and I'm having 100 rupees note, ideally both of them have equal meaning in the market. That is what the meaning of it. So today, in today's session, we are trying to learn how to build our own cryptocurrency. Congratulations, we are building our own cryptocurrency today. By the end of next 1 hour, we are confident that we'll be building our own cryptocurrency. Fine. So as we start yesterday, we'll start opening the remix. By the time I am sharing you something, kindly try to open up this particular tab, remix.ethereum.org. Till yesterday, we have done basically something similar to this, where we understood how to write very simple Solidity program, where we write the version of it, where we write the contract name, where we start writing about what is a constructor. We also discuss something about something as a function. We also discussed in theory what is an event. We also discussed what is a structure, association, and mappings, and so on and so forth as well. In theory, we discussed something. Today, we'll try to implement some of them, and more so, we'll try to work around by building ERC720 standards compliant token. That is, in one sense, we can also say as cryptocurrency as well. So by the time I talk about ERC20 and other details, I request you to open your tab in your browser for remix.ethereum.org. Has everyone? So this is an interactive session where we'll be programming as I am specifying to you. Right? So I hope if you are not driving or you are having in front of your system, you would have done by now. Let me know once you have opened remix.ethereum.org so that I can move further to discuss further. You can say, Priyansh. Okay, thank you so much, Shiva. Priyansh, have you done that? Maybe not. But okay, some issue on my side. So, okay, thank you so much. And Chirag, you can also open your browser and start using remix.ethereum.org. Okay, now what is ERC20 standard? So anytime when we are creating a currency or cryptocurrency, it may be possible that I may have I may have one cryptocurrency and it has one other standard, somebody has other standard, but basically somebody had to come to a consensus that this is what a cryptocurrency should look like. At least some basic characteristics should be there. Otherwise, as it used to happen in the past, back in 1300, 1400, 1400s, people used to give the salary in the salt as well. Earlier, the salary was also given in form of any basic commodity like wheat as well. People used to work for the kings, and they used to give the salaries and wages in the form of salts and wheats as well, and that used to happen for the barter system. Slowly, we moved to a coin-based system where the coins were made in copper and other metals. But there must be some standard for making a coin, isn't it? The coin should be difficult to mint. The coin should be having some standard as well. Otherwise, they should be filing starting on the edges. So as in case of real life, you also have some standard for ERC20 token. And what is the standard for it? Okay, what do you mean by a token? Token means it should have a reputation. That's, of course, in an online platform, somebody should say that if I'm giving you some token, let's say the token is maybe Vanshiraj token, let's suppose. And if everyone accepts the token named Vanshiraj token or a currency named Vanshiraj currency, then only it has a value. And some examples are also given, like lottery tickets and financial assets and currencies and gold and everything, much more. What is ERC20 token? I'm referring to this particular document. For ERC20, you can also refer it up similarly while we are moving further, that I am talking from this particular source. Now, ERC20 standard, there are certain things that means it's a fungible token. The word fungible seems to be somewhat complex, but meaning is that it can be replaced with anything other. Of course, we need to have some accounts, then we need to create smart contracts, and then there are certain token standards. Let's talk about token standards first, and then we will start working across building today one of the cryptocurrency. Right? Now, what is ERC 720 standard requires? What a functionality should have? Okay, I need to transfer this token from one account to another. At least in our online community, where in our Ethereum network, we should be able to communicate or transfer the token from one account to another. I'm sure that must be very clear to you. That is then only I can have some online presence. If I cannot purchase something, I cannot transfer one token from Chirag's account to Vanshiraj's account. It doesn't make too much of a fun for me. Of course, I can also see that how much is the current token balance in my account. That is also very important. I need to also see that what is the total supply of tokens available in the network as well. That is very, very important. And also very important feature is that I can tell Priyansh to spend that token on my behalf. That was not possible earlier, unless I gave Priyansh my ICICI Bank net banking user ID and password. Still, there is a verification code that happens in a mobile phone. But here, in this particular network in Ethereum, I am allowing somebody else to spend on my behalf. And we will see, we have seen when we are using some exchanges, maybe WazirX or Binance or CoinDCX, we generally try to do similar type of things where we tell CoinDCX, you can spend on my behalf. And in that way itself, it may be possible that the entire thing might not be written itself in the chain as well. And they are earning thousands of dollars every day just because of the fact that they are on one of their accounts, the money is getting transferred and traded. In the sessions to come across, we'll build our own cryptocurrency as well. So you may be thinking of yourself having your own cryptocurrency, maybe Priyansh chain or Priyansh X or Chirag X or something like that. And Vanshirajan's, something like that you can think of, maybe we'll be building. So this was something, the purpose of ERC 720 token and what are the basic functionalities. Something we need to know that in these functionalities, something that must be there. But before moving on to that, some methods or some events that need to be there, I would like you to say something. That do you have any questions, something you want to say regarding ERC20 token, where in the terminology we are saying ERC20 token, but we know that it's nothing but a cryptocurrency which we are creating. Okay, and now let's start building upon with the functions that we are trying to create. So function, this is a definition or declaration of the function, that this function should be at least like that. That means the function should have a name. The name can be anything. The method name is the name that this is the function. It should have a symbol. That's okay. It should have a function named decimals. That's okay. It should have a function named total supply. That whenever a ERC20 token is created or cryptocurrency is created, These are the functions that must be there. So this function returns the name of the currency. It returns the symbol of the currency. It returns how many decimals. And when we're talking about decimals, decimal means till how much decimal places this currency holds the denomination. For example, if we talk about rupee, generally 2 decimal places. Sometimes I was surprised that in my bank account, company's bank account, I saw that my currency is ABC. I mean, let's say 5 rupees dot 123. So I mean, I was very surprised to hear that my account was saying that my current account is dot 005 rupees or 5000.005 rupees. So I was very surprised to hear that rupee has gone into 3 decimal places. Similarly, we can also see that there are many places where the decimal denomination goes to 4, 5, 7. But in Ethereum network, we go to 18 dot decimal places. So if somebody is working in one of the decimal places, that means that is till 18th decimal. So we'll just understand that when we are going further. But understand from the terminology that if you're having 1 paisa, that means it is 2 decimal places denomination in the rupee currency. So if you're creating a currency, let's say Naman currency today, Naman cryptocurrency, and that means we can go, and if you're having a decimal places 5, that means we can go till the 5th decimal places and spend something to purchase in that online network. But here in Ethereum, we go to 18th decimal places for general purpose as well. We also need to have a function that gives us total supply of that particular cryptocurrency. What is the balance of for a particular address? How much balance of that currency that is held by that particular account? We can transfer from one account to another that cryptocurrency. We can also transfer, specify that we are transferring from something. We can approve. Transfer from is a function. That means if I am approving Vanshiraj to spend on my behalf, so Vanshiraj can use this transfer from function to transfer from my behalf as well. But before that, I need to approve Vanshiraj that he can spend on my behalf. So there is an approve function as well, and there's an allowance function as well that we'll specify when we'll see very soon that I can allow somebody to spend on my behalf as well. And approve means this much amount of currencies I am approving on to spend. So these were some methods that we may use. There are some events that as soon as some transfer happens, we can trigger that event or emit that event. That means whenever something happens, whenever we're emitting an event, we are writing the things on the log file as well. And similarly, when we're approving an event, that means we can trigger that event approval or emit that event. That means these things can be written in the log file and somebody can take an action looking at the log file, which is visible to everyone in the chain. That was basically it. If we have these functions, we can create our own cryptocurrency. It is as simple as that. Fine. Now that's it. That is it. That is what we'll be creating today. We'll be creating a cryptocurrency which has a name, symbol, total number of supply, how many decimals we are going, and we'll be writing all these functions. We may be using some different events as well. With that, we may be good to create our own cryptocurrency. Fine. Excited? And yes, in today's session, we'll be creating our own cryptocurrency. And once we have created our own cryptocurrency, you can specify that yes, there is a cryptocurrency named Vanshiraj coin or something like that in my name as well. Okay, now let's start creating our own cryptocurrency. You might have already used opened remix.ethereum.org. In that particular session, we will go ahead and create our own cryptocurrency. So I have already written a particular contract for the sake of easiness or for the sake of quickness, so that we can do it in a quick time. But we can do it right away as well. We'll be switching back and forth. I'm sure that you have that particular method or the file with you open at some place, this one. And now using this particular file, I will be switching back and forth. Only these particular functions I want to create. That's it. And we already have a skeleton ready with us. So we know how to start writing. We know how to create the name of the particular contract. And we know also how to write a constructor. That's it. I mean, we have all the basic commodities in place. Let's start writing our own cryptocurrency. That is fine with it? Just basically simple working about the names and everything else. Fine. So now we can we should have a function. As you know that in the last session we have seen that anything that is having the public access specifier, that is tokens, we can access this from outside as well. So instead of creating a particular function that returns to us the name, we can always create a public specifier, maybe let's say a string, and when we are calling that particular string, we can always get the name of that particular coin as well. So what I am specifying here is that instead of using that, we can always specify, let's say, string, and in that particular string, we can always name that particular coin, whatever name we can give it up. So let's say we are naming that particular coin, we will give the specifier, access specifier, and let's say the name of the particular coin is equal to, what do you want to name this particular coin? Today we are creating cryptocurrency. Come on, be creative. What cryptocurrency you want to create? What is the name of the currency you want to have? Okay, Bitcoin or Bitcoin, Priyansh. What do you want to have? Bitcoin or Bitcoin? BITSCOIN. Okay, I got it. So let's create a Bitcoin. This is the cryptocurrency that we're creating. The name of the cryptocurrency is Bitcoin. What else do we want to have? Okay, let's look at here. We need to also have, we have a name ready. We need to give it a symbol as well. So let's give it a symbol for this. Similarly, we give it a string. I think the font is a bit smaller. Is it visible now? I think it is for us.
Yeah, it's visible.
Yeah, thank you so much. Okay, now let us create the symbol again. And what do you want to give the symbol here? Let's say it is called as bits. I mean, for sake of simplicity, let's give it a Bitcoin we are creating, and the symbol we are creating bits itself. Fine. Let us move ahead. How many decimal places you want to have? And we go ahead in this particular place. We say that some decimal places we need to create. Generally, the decimal places are till 18, and the data type we have to use is uint8. Let us use it uint8 and create. And the thing we are creating decimals, and we are creating 18 decimal places we are creating. So we have satisfied first three criteria here. We have given the name, we have given the symbol, we have given the decimal. Let us create total supply as well. And when we are creating total supply, then what is the data type that should be there? That is again in uint 256, and we start with it. And we give it total supply. That is, sorry, total supply. This is the name of the function that we are having, and we are fine with it. Total supply is the name, and let us give the total supply how much you want to have. Do you want to take it from the user as well? How many coins does it want to create? Initially, it may be, let's say, 10 million. We can give it up here, or we can also take it up from the user as well. Let us initially assign it something. Okay, so this is 1 million. Let us give it 10 million of them, which is 1 crore. Right? So I hope that is clear for you, that we have created a coin which has the name, which has a symbol, which has a decimal, which has a total supply for it. Right? Now, next we need to create the balance of as well. But for the balance of, we need to have some addresses, isn't it? So let us try to create some addresses, and from that portion, we'll try to move across from there. And when we are creating some addresses, we need to make sure that addresses are mapped to some value as well. So if you see that here we want to create the balance of. That means whenever we are passing some address of any particular account, it should return how much balance that has. Instead of having a function, or in a better way, we can also create a mapping, and in which mapping is a data structure in which when we give one of the input, it gives out the other output. It works as a function, but basically mapping is a associative array. Have you heard of associative array? It means it's and to define a mapping, we need to write something like give a symbol mapping, and we need to define from where to where, and let's say uint8, that is what we are giving it output, or uint256, that is the output that it returns. So if you give out an address, it gives out uint256 output. So we are creating uint256 output, and let's say we are giving that particular name something, maybe some function, or the name of something that is of public, let's say, and public, and let's say this is right. This is a cryptocurrency that we are creating in today's session, and here we have made the cryptocurrency. Let's name the cryptocurrency Bitcoin. We have given a symbol, we have given a decimals, and the total supply is 10 million that we are creating, in which we also created a function or an associative array where we give one of the addresses, it returns the balance. In this cryptocurrency, when we are creating, we are also having a function whose name is transfer, which allows the transfer of cryptocurrency from one address to another. So let us start creating that particular function transfer, which takes up an address, which takes up some value as well, how much cryptocurrency that you want to transfer, and ultimately it should return success or failure. So not only it should take up an address, it should take up how many coins or how many cryptocurrency you want to transfer. Ultimately, it should return success or failure. Let us copy this exact function and use it up in our cryptocurrency, where we are using this transfer, and let us try to write the body of it. Right. So this is exactly the same thing we should be doing. What should happen in this particular place? That ideally I should have an address. On that address, I want to transfer that particular thing. As simple as that. But before that, do you want to make some checks as well? That it should be possible that I need to have that much currencies as well. It should be also that it should be a valid address, isn't it? Seems to be logical, isn't it? But how do we check that? Do we have enough cryptocurrencies in my account or not? While we have not assigned, we have created some cryptocurrencies, but we have not assigned those coins to anyone till now, isn't it? So in the constructor, we can assign those coins to someone, and then we can play around with it, isn't it? So let us play around with this particular thing where we are playing around, that we are assigning up something, and then we are also making sure that the things are working in a proper fashion. Okay, now in this function, we are having let us assign it up. If you remember yesterday's session, we had already seen a particular particular inbuilt function which is called message.sender, msg.sender. If you remember that, which gives out the address of whoever is calling this smart contract, isn't it? If you remember that, this is the msg.sender. Now here we want to make sure that the account for this particular addresses has all the currencies that we are creating. So let's say we use balances dot message dot sender, and we are assigning all the currencies that we are creating in with that particular name. So initially it may be that this is not 10 million coins, but it should be 10 million into 10 raised to power 18 that should be created. So suppose if I want to create 1,000 rupees similarly, but internally the 1,000 rupees is not 1,000 rupees. It is talking more in terms of paisas here. We need to create, if paisas is a denomination of 2, we need to create 1,000 into 10 raised to power 2. Those many total supply we need to create. So here, if you want to create 10 million of them, then we need to make sure that we are having into 10 raised to power 18 those many coins which we are creating. And suppose if we have created that, and now we are assigning everything that we have initialized to that particular address. And now one of the addresses holds these many tokens, and from that we can play around and transfer to some other particular address. When we are starting with it, we need to make sure that this address has those many tokens to transfer it up, and that function will check up if that is there, so that we use some assertions, and we can look back. And here we are using some assertions. We're using require assertion, and what is assertion, how do we use that. We'll always look ahead and search in Solidity docs to find out what is the correct way to use anything further. There are a few things which we can use. We can use assert, we can use require, we can use something more. And the difference is in front of you, where to use assert, where to use require, and what is the difference from it, and what are the other assumptions that we can always use. So here we are using require, but there is a correct way to learn from them, some basic types from that we can use, and in these types, there may be somewhere where you will find out these assertions. Fine. In the correct way, we can always look at this particular document from where we learn about what is the correct use of this particular assertion. So here we'll require one of the assertion, that is require, to make sure that the balance of that particular token is at least this much. So I start with it, that is from which particular address I am transferring. Inbuilt, we are transferring from the address which is calling that particular function. So which function it is calling, that means the same function from which the contract is used. So we have to check balances, or the balances here, and we have to check of message.sender. It should be at least greater than or equal to the value that we are using. And that is what we need to check it up, isn't it? If that is failing, that definitely is the parameter where we will make sure that it doesn't go any further. And after that point of time, what do we need to do? We need to just subtract from one account and add into the other account. It is as simple as that, isn't it? So then we need to just make sure that the transfer happens. And when suppose I am transferring from my account to, let's say I'm transferring to Chirag's account, let's say 10 coins. Oops, I did not share the particular tab. And when I'm transferring from my account to Chirag's account, at that point of time, I need to make sure that I have basic tokens. And once the transfer event is properly executing, that means that from my account, 10 tokens are deducted and bits coins are deducted, and from Chirag's account, 10 bits coins are added. That's it. So let us move further and do the rest of the basic simple calculation. So what do we need? We need to just make sure that balances, that is the place where we are holding the number of coins that any particular account is having. We'll make sure message dot from that account, the amount is reduced is equal to minus, this is the amount that I'm transferring from one account to other. So this thing should happen, and from that, the other account, that is to account, to this account, the balance should increase. So I'm starting, and in this account, I am adding that many things. That's it. So this is very simple. We have created something, we executed that. And right now, let us not worry too much about the events that we are using, but at least we have done something here. So without even waiting for creating the entire currency, let's try to compile it up and see, does it work for you or not? Fine. So are all of you here? By the time I will compile something, you may be having written something, the same code. And let me know if you are with me in this particular program. Fine. Are all of you able to see and able to understand what is going on?
Yes, sir.
Okay. Any questions you have, Vanshiraj or anyone?
So what will the require keyword do here?
Yeah, require keyword will check if the in between parameter, if it is true only, then only it will work. Otherwise, the require keyword will flag an error and it will drop out of this particular function. You will check that in between statement is correct. It will.
Okay, so
if it is false,
if the required condition is not true, then the program will not move any further.
Yes, it will drop an error and come out of this particular function.
Okay, understood.
Yeah. Okay. Anyone else would like to ask something? Priyansh, Deepak, Shira, are you able to type as well? I am as we are also doing. You have typed till here? I mean, in your remix.ethereum.org. Yes, no. Okay. Okay. Now I think you are way ahead, Priyansh. Let us try to work ahead and compile something. So here we are using. You are seeing again the same tab. We are doing that, and we're compiling new.sol. And let us see. There is some warning. There is some error here as well, which says the address balances is not a good one to use. I think we might have done some mistake. Okay, I think there is some error here. We have not used the correct word, which is, I think this is address. I think this is very poor thing from my side. Okay. Okay, now something is there which is saying balances, total supply. It is showing an error. What is the error? It is saying balances measurement is equal to undeclared identifier total supply. I think total supply we have declared, isn't it? Okay, this is in small. Okay, let's compile once again. Now this is having a warning, and this is a boolean because we have not given an output, so we can return it till this point. We have won. We can return to, and that is great. Okay, sorry, I think this is not in this particular fashion. We can return true directly as well. And let us try to compile it here. Okay, there is a simple warning because you're not connected to the main network. I hope you all might have gone till this point. I can just copy this code and share it with you. If you are listening, have you compiled? Have you written code this till this point? Yes. No. Are you writing it up? Okay. You can look at this program as well. I have given in the chat box. If there is some error, something you can see for it. Right. Chirag, are you writing side by side as I am speaking? One Chirag.
Sir, I'm not on my laptop right now.
Thank you so much for letting me know. That's great. Others may also specify if you are facing any error, so that I will be back able to.
No error.
Oh wow, so nice. And how about you, Priyansh? You were already compiling something, I think. And Deepak, maybe you joined a bit late, but we are trying to do some basic programming of in Solidity, which is a basic native language of Ethereum. The primary idea is that while we get the capabilities to do some programming, we are able to build decentralized application that can solve some problem in the real life. So we're trying to build some basic decentralized application. Here today in this session, we're trying to create our own cryptocurrency. And the name suggested by many of us was we are creating Bitcoin. That is the name of the currency. Right? Okay, let's try to. It wasn't compiling, but just writing the code. So yeah, that's okay. We can just go at this particular tab, and that we can compile it up. That's it. Then the compilation is done. Right. Okay, now we go towards this button and let us deploy it up. Here we are deploying it up in the test network. Again, as we have seen in the last class, we are deploying and we see that something tick mark has come up. That means our deployment is successful. This much gas has been used. That's fabulous. We are able to deploy it up in the test network successful. Now, what else we can do? We have seen there is a contract that is created, which contract name is token, and this is similar as this one. Let us move ahead and let us see what is there in this particular token. There is a function that is created transfer from which we can do something, transfer from address and a value. We can play around with this particular function as well, primarily because this function is of public value and we can call this function from outside this smart contract as well. And there are some things which we can also check up as well. We can give up something in the decimals and we can give it an address because it's an mapping. If we give an address, it will return the value for it as well. And for others, we can always inquire that what is the value of decimals. It is returned. It is decimal 18. The name is Bitcoin. The symbol we're using is bits, and so on and so forth. We can always test with it now. And test one, I'm not sure what is it. It may be somewhere else. let us, okay, the public, some addresses, we don't need it right now. Okay, sorry, maybe let it be like that. And supply is this many, 10 million, and after 18 zeros as well, that is there. Okay, let us try to transfer something, but let us try to understand, is this function working or not? Is the constructor working or not? What is message.sender? Message.sender is the address from which we are calling this smart contract. What is the address? This is the address. So in this test network, we are having 10 different accounts, and from this particular account, we are deploying this particular contract on the test network itself. So try to check it up. Does this address actually held that many tokens? How many tokens should be there? These many Bitcoin should be there. Let us check out with this and try to check out this. We are giving this address, and ideally, when I am returning, this should return. I am giving an address. It should return the UINT 256, which is I have just initialized here. It is root of supply. Let us check it up. We'll call it up, and behold, we have done it very nicely. Fine. And we can also play around, and we can transfer from one account to other. Let us try to do that. I am transferring from account is the same from which we are calling this contract, and to account, let's say I am transferring to the account 2. I am copying it here, and similarly the account is still called from the main account from which it is deployed. Let us say I am transferring to this particular address. How many tokens? Let's say I am transferring 10,000 tokens. Let us transact, and okay, wow. Because when I'm transacting something, the state of the Ethereum is changed, and it will also consume some gas. Some gas is consumed, and we say that it has become a success. Now, what should happen in this? That this account should have these many tokens that I have transferred. Let us check it up from the balances. From this. I think I should enlarge it up. You should specify to me that you are not able to see it up. And now in this particular thing, I am having this contract which is ending by CB2, and this is the contract. And ideally, it should have these many coins or bits coins with it, because these many coins have transferred to this particular address. Let us check it up, and yes, exactly these many coins are there with this particular contract. So now we have done something basic. We have created a smart contract where we have some symbols and some basic data types. We have created first function to create our own cryptocurrency, that is transfer. Or are you able to follow? I think if you have understood something, it is just another way of we are taking an action and specifying that yes, whatever you have written is actually working. It's one way to say that if you study, you will get this output. But here we have done something, and we are getting the output right away here in it in front of us as well. So I think Priyansh, Vanshraj, Deepak, are you able to understand? And if you are able to deploy, are able to run it up as well?
Yes, sir.
Oh wow, that is great. So you can test it up, and Priyansh, maybe you can also let me know if you are able to do it up as well. Are you able to follow? Okay, maybe after this particular thing you can join. Yeah, no issues, Deepak. It has nothing to do with yesterday as well. It's something a bit new, but yesterday is a build up from here. Yesterday we discussed some basic building blocks of Solidity programming. Today we started it completely afresh. But I hope if you have some technical or conceptual doubt, you can always ask it up. And it's your right, because you're devoting your precious time to this particular session. So irrespective of whatever I have discussed and you are not there, still you have the full right to understand. You can ask many things, even though something has been discussed. I will be happy to answer you. Fine?
Sir, could you please repeat the mapping part?
Yeah, mapping I haven't discussed. Thank you so much, Vanshraj, for taking it. So mapping is basically a data structure where it's a data structure of the form. I can maybe start something. Something I need to. I will start a whiteboard here. And in the whiteboard, I will try to explain what is happening in the mapping. Mapping is basically a data structure where we are creating from one particular so many of addresses are there. So from one address, we are assigning, we are equating to other. Okay, you might have heard of some arrays. You may be exposed to arrays. What is an array here? In the array, we used to have, let me start with this particular function. So this is an array here. In the array, what happens is that there are fixed number here that starting with 0, then there is 1, then there is 2, and depending upon if it is fixed size array, we can have, let's say, the n here, and here we can access them. This is the index number, and the value here, it is whatever we are initializing up. Let's say the value we are initializing be 5, there will be 5,000, there will be, depending on data type, that will be 50,000, something like that. So whenever we want to access the value here, whatever is defined, we'll give that, let's say array name is A1. So A, and when we are defining A2, that returns the value that we have stored or initialized at that particular location. I hope so far that is clear to you. Am I making sense here, Vanshiraj?
Yes, sir. Yes, sir. It's clear.
This is what we know of. Yes. Now let's try to understand what is the mapping here. Mapping is something, we're not defining the fixed number here. This is not there. We're just saying that there is a bunch of things that may happen, and you can pick up any address. The first thing that you can assign that address here as well, and tell me whatever address. And now in that address, I will store upon whatever so there is nothing 0 to 9 or nothing there in this particular left hand side here. In that left hand side, only we have to define that yes, it is a mapping from addresses. That means on this particular side, you may expect something of the type of mappings. On the right hand side, you may expect something of the type of unsigned integer. And we are just associating that anytime we can give some address and use this data type called as mappings, whose name is here we are defining here balances. So as we have seen in the arrays, in the array, let's say the name is A, we're defining this particular data type with the name, let's say balances. And in the balances, we can always say from this to this, and from means it's an address in the from side, and to means it's a integer that we have defined, unsigned integer that we have, and we can have any number of them that we can define in balances. So once we have assigned these balances, we can always give up this particular left hand side address and check out what is on the right hand side as well, as we have seen in the array thing. But here we're not limiting 1, 2, 3 or 5,500. We can have any number in the left hand side, but whenever we're giving anything number on the left hand side, we have mapping to something on the right hand side, which is, according to our definition, should be a mapping from addresses to unsigned integer to 56 value. I hope that makes some sense to you.
Yes, sir. Got it.
Yeah, this is something in different languages. It is called as associative array. Another data type which many languages heavily exploit, and Ethereum is one language that is also using it.
So
Okay.
what I remembered of is like when I was studying this dictionary in the Python, the key value pair thing.
That's exactly the same. This is exactly a key value pair. Yes, you are right. So your connections, is that something you already know of? You have connected it up here that the key value thing in Python is same as the mappings in Ethereum. That's it. Exactly the same. Great. Great. So I think we have touch based quite a lot of things. One of the things that you can do is that maybe coming tomorrow, I thought I would be creating cryptocurrency today itself, but I think we have made a good strides further. We'll try to create cryptocurrency in the next session.